All right, guys, we are going to start 4.2. However, I had a couple of the same question over and over in first period, so I wanted to kind of start there today in case anybody in here had the exact same question. On the homework, there are some questions that ask you to write the interval for f of x greater than 0 and f of x less than 0. We have done this, and we did cover it. We didn't write it out like this, but we have covered this concept. What does f of x represent? Y. And y is another way of describing our output. Where would I look on the graph of a function for my output? Yeah, I don't want to be looking left and right. That would tell me about my inputs. I want to look up and down. That tells me about my outputs. So where would I look for where my output is greater than 0? Which side of the x-axis am I looking at? The positive side, the top side. Your sign charts give you the exact same information, or you can get this information off the graph. So if I wanted to know the intervals for where f of x is greater than 0, where on this graph right here is my output greater than 0? -3 to -1, and because I just want to know about where it is strictly above, I'm going to use parentheses, not brackets. Is it ever above the x-axis anywhere else? Yeah. Yes, then I need a union 2 to infinity. Where is f of x, my output, less than 0? -infinity to -3 and -1 to 2. So the same information that we've gotten off the sign charts in the past, just make sure you understand this notation. Like I said, I know we didn't do this exact notation in the notes, but we did cover that concept. So if you guys had that question from looking at the homework last night, hopefully that helped clear that up a little bit. You can always make a sign chart if you want to be very, very sure of it. You do have to graph these on the homework, just like we did in the notes. If you need more graph paper from me, please just let me know so that you can do those graphs. All right, so from there we're going to pivot and jump into properties of division, 4.2. Properties of division, yes ma'am. Absolutely, yes. Yep, if you want to put it in either one of those baskets, whichever one is free on a given day, absolutely. You can make sure they get it that way.
Thank you.
You're welcome. All right, so properties of division. We're going to start off with the basic division algorithm. Division algorithm for polynomials. If f of x and p of x are polynomials, and p of x does not equal 0, super important, then there exists unique polynomials, q of x and r of x, such that f of x, my original polynomial, is equal to p of x times q of x plus r of x. Let me break it down and explain what you already know about the way numbers work and polynomials work the exact same way. So I can take any number, say 13, and I can write this as the product of two numbers plus another number. So I could say that this is 4 times 3 plus 1. I'm going to do this exact process with polynomials. I can get to any given polynomial that I want to by multiplying two polynomials together and adding whatever else I need on top. Does that make sense? Okay. It's really important when we're talking about this that p of x, my divisor, is not equal to 0. This would be the part that's on the bottom of a fraction. That's why it can't be 0. Now there are a couple stipulations on R of x. R of x either has to be 0, this is my remainder, or the degree of R of x is less than the degree of P of x. So when I'm thinking about polynomials, I have to think about the degree of my polynomials here. My remainder can never have a degree that is the same as my divisor. The polynomial q of x is my quotient. R of x is the remainder. So we're going to revisit what you guys have done already in Algebra 2 with polynomial division. You guys learned 2 types of division. You learned polynomial long division, and then I'm assuming that you were also shown synthetic division. We're going to revisit both of those. I'm going to practice with long division first. Synthetic division is only allowed to be used with linear factors. So if we have something that is not a linear factor, if P of x is not linear, I have to use polynomial long division. F of x, my first polynomial here. This is my dividend. This is what goes inside or underneath my long division symbol. Yes, this is the piece that is being divided. Absolutely correct. P of x is my divisor. This is what I'm dividing it by. This is the part that would go on the bottom of a fraction if I was writing this as a fraction. This is my divisor. All right, so I'm going to write those pieces down. We're going to take 9x plus 4. We're going to divide that by 2x minus 5. Who remembers where to go from here? After I write down my long division algorithm, what do I do from there? 2x times something equals 9x. Yes, because then I'm going to subtract. And my remainder, remember, has to either come out to be 0 or the degree has to be less than what's on the outside. What degree is this on the outside? First degree. So my remainder has to be less than a first degree polynomial. So I need my x to completely cancel out here. What would I multiply 2x by to get 9x? 4.5, or I could write that as the fraction 9 over 2. You can write 4.5. I'm going to leave it as a fraction up here.
My brain is not awake enough to be doing fractions.
That's fine, but we're going to have to distribute this, which is why I'm going to leave it as a fraction. Because I need to take that now and I have to distribute it to both of these pieces out here. So I have to take 9 over 2 times 2x, which would give me 9x. And then I also have to distribute it here to this negative 5. 9 over 2 times negative 5. I can do that one in my head a whole lot faster than 4.5. 9 times 5? 45. So negative 45 over 2. All right, so after I distribute, what do we do next with our division algorithm? We need to subtract. We need to switch the signs. We're going to subtract that entire thing. Copy, change, change, if you guys remember that. So I'm going to do 9x minus 9x. That cancels. And then I have 4 minus negative 45 over 2. So if I subtract a negative, that's the same as adding. So I have 8 over 2 plus 45 over 2, 53 over 2. This is my remainder. So this is r of x. So I'm going to write that over here. R of x equals 53 over 2. This piece up on top, 9 over 2, this is my quotient, q of x. So q of x is equal to 9 over 2. And I can check to make sure that I did this division correctly by applying my division algorithm. Our original function, f of x, is supposed to be equal to the product of p times q plus my remainder. Let's go ahead and verify that we did this correctly. So I'm going to check. That f of x is equal to p of x times q of x plus r of x. Just like I was able to break this down with numbers, with these integers here, I'm going to verify that this worked with my polynomials. What was p of x? 2x minus 5. We need to multiply that by q of x. What was q of x? 9 over 2. And then we're going to add our remainder. What was our remainder? 53 over 2. So order of operations says I do my multiplication first. So I'm going to distribute 9 halves to both pieces here. What is 2x times 9 halves? 9x. What is negative 5 times 9 halves? Negative 45 over 2 plus my remainder of 53 over 2. So I've got these like terms to put together here. Negative 45 over 2 plus 53 over 2. 4. What was our original function f of x? 9x plus 4. So we did our division algorithm correctly. We found the correct quotient, the correct remainder.
How did you get to check that each 9 halves?
How did we get 9 halves on top? I knew from the definition up here that the remainder either had to come out to be 0 or it had to have a degree less than my divisor. My divisor was a degree 1. So since this was degree 1, my divisor was degree 1, I needed something that had a degree less than 1. So that meant my 9x had to cancel. So then it became, what do I have to multiply 2x by in order to get 9x so that it will cancel out? Does that make sense?
How do we get to, like,
Right here?
no, I'm saying, like, when you're doing the long division, like, can you go over how to do the long division?
Yeah. So
I got the
are you good with how we got the 9 over 2? So then I take this and I distribute it. 9 over 2 times 2x. So the 2 cancels with this 2. I get 9x. 9 halves times negative 5. So off to the side, if I'm going to multiply fractions together, I have negative 5 over 1 times 9 over 2, top to top, bottom to bottom.
So when you're talking about going a degree under, let's say that was 9x squared, would you have to go all the way into 2x? Would you have to go all the way still for the 9? Would you do
Guys, I got a fantastic question over here. So the question was, if this was 9x squared, but this was 2x, would we still have to take it down this far? Yes. I need a degree lower than this piece on the outside. So since this is a first degree on the outside, I need something that is less than a first degree as my remainder. So I would have to keep going until I have something that doesn't have an x. Let's look at another example that I think gets more to your point. Let's look at this one right here, because here my divisor is not a linear polynomial. So I've got f of x, which is this big long piece here. This one goes inside. It's my dividend. Got this piece over here. This is my divisor. This is going to go outside. What degree is my divisor? 2. Second degree polynomial is going to go on the outside, which means my remainder has to be first degree or 0 degree. I have to have a remainder that is less than a second degree. So remainder must be less than second degree, according to the rules of my division algorithm. All right, so I'm going to write f of x underneath my long division symbol. So 2x to the 4th minus x cubed minus 3x squared plus 7x minus 12 divisor on the outside, x squared minus 3. And I have to keep going until my remainder is less than a second degree polynomial. How are we doing so far? X squared and 2x to the 4th. What would I multiply x squared by so that I can make 2x to the 4th cancel? 2x squared. I take that and I have to distribute it to both pieces out here. So I'm going to have 2x to the 4th minus 6x squared. I've got to bump it over so that I've got it underneath the same degree. And then we are going to subtract all of this. So change both signs. We subtract both pieces. 2x to the 4th minus 2x to the 4th cancels out just like I want it to. We're going to drop down my minus x to the 3rd because it's just subtracting 0 from that. There's no like term to cancel with it. So negative x cubed, negative 3x squared minus negative 6x squared. 3x squared. Drop down my plus 7x. Drop down my minus 12. Can I stop here?
No,
Why not?
because you still have x cubed and x squared.
My remainder, the degree of my remainder, is currently higher than the degree of my divisor. So I have to keep going. X squared times what would cancel out with negative x cubed?
X
Negative.
first,
Negative x.
negative.
So minus x. Now I have to take that minus x and distribute it. Negative x times x squared gives me negative x cubed. Negative x times negative 3, I get a positive 3x. After I distribute, I have to subtract. Negative x cubed minus negative x cubed cancels out. I drop down my 3x squared. 7x minus 3x, 4x. Drop down my minus 12. Can I stop here?
Yes, but you're not gonna let us.
Can we stop? Why not? Yeah, it has to be less than. Right now they're the same degree. My remainder has to be less than the degree of my divisor. So I've got to do this one more time and then I can stop. What do I multiply x squared by if I want to make 3x squared cancel? 3. So plus 3. I take that and distribute it. I get 3x squared. 3 times negative 3. I get negative 9. We're going to subtract this entire thing. 3x squared minus 3x squared cancels. I drop down the 4x. Negative 12 minus negative 9. Negative 3. Can I stop yet? Yes. Why? It is less than the degree of my divisor. Absolutely correct. It's not even possible to keep going. Because what would you multiply x squared by to get 4x?
Can you do 1/2, like x to the 1/2 power?
Not to the 1/2, but to the negative 1. But as soon as we have x's with negative powers or x's in denominators, it is no longer a polynomial by definition. Exponents have to be positive in order to be a polynomial. So I cannot proceed forward if I'm going to stick with polynomials here. So here's my remainder, r of x. So r of x is equal to 4x minus 3. That's not the only thing I was after, though. I was asked to find r of x and what? Q of x. Where do I find q of x? Yes, that's the piece up on top. Here's my quotient q of x. So q of x is equal to 2x squared minus x plus 3. I heard a really good question on the previous example that I did not stop and answer because I had a couple questions going on. The question that I heard on the previous example is, do we have to check on each and every problem? No, you don't. But checking is how you can know for sure that you executed the division algorithm correctly. And that is why our division algorithm works. So if you want to go ahead and check this problem, you are more than welcome to. For time purposes, I'm going to skip the check on this one. It is not a required component. You guys okay with that? Okay. So we have revisited long division. I want to also revisit synthetic division. And we're going to revisit synthetic division in the context of our remainder theorem. The remainder theorem says that if f is a polynomial function and I divide it by x minus c, x minus c would be a linear factor. There are a lot of theorems in math. In fact, after calculus, you start doing math without numbers at all.
What's after calculus?
Depends on what you want to do.
For the final, do we get cheat sheet?
Theorem
No.
sounds like theory, and there's a lot of them in math. So if you think about it, math is theory.
Math doesn't even real.
Huh?
Math doesn't even real.
Math is real. It is the only science that can prove things.
But it can't prove itself all the time.
That's not true. Physics.
Nothing can prove itself. You have to start with axioms. You have to start with a base level understanding of what we're all agreeing to, and then you can build on that.
Physics is logic.
All right, so one thing that I want to point out, we did long division on the previous two problems. If my factor is not linear, I have to use long division. If my factor is linear, then I can choose long division or synthetic division. So I'm going to revisit synthetic division on these next couple problems so you guys get a little bit of practice with that one as well. So if I have a polynomial function f of x and it's divided by x minus c, then the remainder tells me what that function evaluates to at the root c. All right, so a couple reminders here. We're going to use synthetic division. We have to use the root, not the factor. And the second thing is that we need the coefficients. We're not going to worry about the x's. We're only going to use the coefficients, and we need every power of x in decreasing order. So use our coefficients. And we must include
Wait, why do we not get a cheat sheet on the final?
I use rules.
Just for the time I use class, we would have a cheat sheet.
Nope. In fact, every IU final exam I took, we did not get a cheat sheet and we did not get a calculator, not even a basic 4-function calculator.
So on the final this semester we won't use one, but next semester we will, right?
Yes, yes. That being the only exception because trigonometry requires either a table or a calculator. Did you have a question, Aiden?
That's a statement.
Or Anthony, sorry, I called you Aiden. My apologies.
Kind of sounds like a IHS quote.
Huh?
Kind of sounds like IHS interesting will suffer.
No, actually, I have yet to find any like high-level institution that in pre-calculus and calculus allows the use of a calculator.
Wait, so this was not an IU class, will we have a cheat sheet?
I don't know. That's a question that I can't answer. That goes into hypotheticals that I don't have answers for.
I mean, if we had a calculator, this would just be like algebra 2.
Kind of.
What if I just let x equal 3 and just do long?
Well, that's the thing. X does equal 3. We're going to use synthetic division with that.
That's what
All right, so
I'm just
x minus 3. So what is my root? Root is 3. I need all of my coefficients from my original polynomial
the hardest one.
in decreasing order, including every power of x. What is the degree of this polynomial? Third degree polynomial. So I need the coefficient on x cubed. I need the coefficient on x squared. I need the coefficient on x. And I need my constant. What's the coefficient on x cubed? 1. What's the coefficient on x squared?
Negative 4.
Negative 4. What's the coefficient on x? 0. And the constant?
5. Well, negative 5.
Negative 5. All right. Upside down division symbol. Root goes on the outside. If you don't like synthetic division and you choose to use long division for these problems, I am okay with that, but I am going to revisit this process so that you guys are familiar with it.
Do we have to do synthetic on the homework?
What did I just say?
Oh, so like for like last year on specific questions, if you like use synthetic division, use long division, or when it's
I'm sure the directions say things like use synthetic division here because it's faster. If you choose to use long division on it, I am fine with that. Anything you can do with synthetic division, you can do with long division. Synthetic division does usually tend to be faster. All right. When we do synthetic division, first number drops straight down. So my first coefficient drops straight down. This would then be the coefficient on the power of x that is 1 degree smaller than my original polynomial. From here, I take my root and I multiply it by that number. 3 times 1? 3. And I write that down right here. And I add it to the number above.
Negative 1.
-1. And then I take that and I multiply it with my root again. 3 times -1? negative 3, and I add it to the number up above. So negative 3. And then one more time through, I take my root. Ooh, that doesn't show up at all. And I multiply it by that number. 3 times negative 3. Negative 9. I add it to the number above. Negative 14. This last number here will be my remainder. So what this tells me, using my remainder theorem, is that f of 3 would evaluate to be negative 14. That is what's stated up above in my remainder theorem. The remainder is f of c. I want to check that to see if it's really true. So let's check over here. So I'm going to do f of 3. So that means I have 3 cubed minus 4 times 3 squared minus 5. What's 3 cubed? 27. Minus 4 times 3 squared. 3 squared is 9, so minus 4 times 9, minus 36, minus 5. 27 minus 36. Negative 9 minus 5, negative 14. F of 3 is equal to negative 14. So question. If the remainder theorem gives me the exact same thing as if I just substitute it in, why do we bother with this?
Double checking.
Double checking, that is a good idea, and that's valid.
Or if it equals something that we cannot have.
What if this was x to the 5th instead of x to the 3rd? Do you guys want to substitute in and do 3 to the 5th in your head? Or what if this was x minus 14 and then we were trying to do 14 cubed? That's going to get really ugly. Using synthetic division, using my remainder theorem, I can get the exact same solution with fewer steps, with less room for error. Let's try another one. What is my root here on part B? Negative 2. So I start off with the same coefficients. My root goes on the outside. I know that over here is where my remainder will be. How do I start this? It's the first thing I do. Bring the 1 straight down. And then what? Yep, multiply my root with that value, so negative 2 times 1 gives me negative 2, and I add them together. Negative 6. And then I repeat this multiplication. Negative 2 times negative 6, 12. Add it to the value above. Negative 2 times 12, negative 24. I add it to the value above. Negative 29. So what did I just find out according to my remainder theorem? F of negative 2 equals negative 29. I'm going to put another problem just like this up. Different original polynomial. I want you guys to practice with synthetic division. Again, on the homework, I don't care whether you use long or synthetic if you don't like synthetic division at all. But right now, I want to get some practice with synthetic division. And this is where we're going to end for today. Yes, ma'am. Yes, absolutely. I want you guys to practice with these two linear factors.
But you said on the test she wouldn't. She wouldn't specify.
So that's why we want to make sure that we have multiple ways to look at it. You don't get a calculator to use on the exam, and some of these values are so large that doing it in your head is just absolutely impossible. Or our powers of X are so high. Because if it was like -3, yeah, then we got it. These are coming from the coefficients up here, and we have to have every power of X. So the coefficient on X is 1. The coefficient on X squared is -4. Then I need the coefficient on X.
Try to run my 5 waves depression too.
So every power of X in decreasing order from the highest power of X all the way down to your constant. You're welcome. Guys, please take the time to practice with these two. I want to make sure that we fit these in before the bell.
Can you tell us the answer from number 1?
There we go. I have my work for part A up on the screen.
Yes, I did this.
You said you did not? Or did I hear somebody say they did not get that? Was it the very last one you were stuck on?
Oh no, I just thought
Okay.
I didn't get that. I just realized I did negative 5.
Ah, yes. I have my work for both parts A and part B up on the screen. Please go ahead and check your work against mine. And I'm kind of curious on part B. What did we get our remainder to be on part B? 0. That's kind of special. That's kind of meaningful. What does it mean if I have a remainder of 0? They're perfectly divided, which means what about x plus 1 if it perfectly divides my original polynomial? Not a y-intercept. I found an x-intercept, though. So I know that -1, 0 is an x-intercept of my original polynomial, f of x. So -1 is a 0 of the function. So what does that mean about x plus 1? If I divided my original polynomial by this, and I get this remainder of 0,
It's a really great question.
starts with an f. X plus 1 would be a factor of f of x. This means x plus 1
And x minus.
is a factor of f of x. Factors are pretty important features when we're talking about polynomials. We're going to pick up with this idea right here. Factors of polynomials. So we're looking for remainders of 0. We're going to start here tomorrow. 4.1 homework is due tonight. 4.2 homework, guys, listen up for just a minute. 4.2 homework is due on Thursday. Here's how the next couple of days are going to go. So again, 4.1 homework is due tonight. Tomorrow we will finish 4.2, and I will pass out a review page for your quiz on Friday. Quiz on Friday is for 1, 4, 2, and limits. So I'll pass out a review page. I'm not going to collect it for points. First thing on Thursday, before we start 4.3, I'll go over the answers to that review page. And then Friday, you'll take your quiz. All right? Awesome.